By the end of this unit, you should be able to describe hypothesis testing in general and in practice. This requires an understanding of why the status quo is the null hypothesis and why the alternative is the contender. You should understand the implications of always setting the status quo as the null hypothesis. It is given that any probabilistic conclusion may be wrong. You should be able to differentiate between a type 1 error and a type 2 error, and the probability of making each type of error. Understanding these foundational concepts allows you to formulate tests of hypotheses concerning a population mean when we do not know the standard deviation of the population. You should also know the appropriate adjustments to the test statistic required if the sample size is less than 30. You should be able to develop and conduct hypothesis tests of a population proportion based upon the same concepts learned about the null and alternative hypothesis and the role of the type 1 and type 2 errors. This unit is our first step into inferential statistics in the form of hypothesis testing. We met inferential statistics with confidence intervals, but hypothesis testing is really the core of this topic. In order to develop a method of testing hypotheses, which is what we did, required us to face the various ways we could reach an erroneous conclusion, to make mistakes in our work. We also had to decide just how confident we wanted to be in our results. All this is because we have conceded that we will never know truth, and will have to be satisfied with a probability in what we have to say. If pride goeth before a fall, then from a statistical perspective, a 100% confidence interval is one manifestation of pride. Statistical analysis is truly a way of viewing the world, a broader perspective on how to approach the questions we face every day, large and small.